Hey everyone, this is Eugene, and together we are with Austin and Matt, and this is another weekly episode of Live Contract Reviews. And today we're gonna review Skyward. Skyward Finance is a platform that I noticed on Twitter. So basically, they said they built the contract for fungible token lockups. So today we're gonna review it. I did take a look a bit on a structure, and they also have like some other contract, I guess, for the platform, but I haven't looked in details into this yet. All right, so let me present. Okay. All right, so basically there's two items that we need to review. One is a lockup. This is a contract, and one is a lockup CSV to Borscht tool. So let's start first with the CSV to Borscht. So it's saying it converts a CSV file into lockup binary input so that can do efficient lockup deployments. How I understand it, it basically takes a CSV and then it creates some file that it calls example out Borscht. That is a binary, and I assume the idea is because it's binary, first of all, it probably takes less space, and second, you may be able to look up in this binary faster, so you may not need to deserialize the whole binary. Anyway, so the binary, well, that tool takes three arguments: CSV, output, and balance multiplier. That's probably to be easier to handle balances. So you can use some common multiplier on every balance. So then CSV contains the account ID, start date, cliff date, and end date in following formats. And then the balance, and this balance will be multiplied by balance multiplier. So in this case, we have two accounts, alice.near and bob.near, and start date, no cliff date, and the end date. And then a balance of 10, and Bob, start, cliff, and end date, and a balance of 10,000. So balance multiplier is 15 decimals, and the fungible token has 18 decimals. I guess, so it means 10 multiplied by 15. Okay, yeah. So Alice has 0.01 token and Bob has 10 tokens. So assuming, for example, this is Ethereum with 18 decimals, then Alice gets 0.01 Ethereum over 1 month, and Bob gets 10 tokens. Sorry for the small font. I don't know how to edit MD previews. So I guess if I switch to editor, it's gonna be larger, but then it's not as nice. Linear vesting in 1 month cliff. So yeah, then the output is this: 2 accounts created, balance, total multiplied balance. So this is actually what the contract probably needs. Timestamp. It looks like a timestamp in seconds instead of nanoseconds. And then, yeah, the binary. Okay. Yeah, I cannot open the Borscht file. Anyway, so this is the binary. Let's look at TOML. Yeah. So it has CSV, Borscht, nearest decay, and chrono. It has Borscht. But it uses Borscht from nearest decay for some reason. Anyway, okay. So we have a record that is JSON. So it has a valid account ID, start date, cliff date, end date, and balance. I guess this is to parse the CSV. Then fixed size account is for serialized. So this is for output. I see, yeah. So the reason it's called fixed size is it doesn't really stores the account links in account ID in a Borscht format, but instead stores it as U8 and U864. So this is not more efficient. Like it would be more efficient to store the lengths and then a vector, for example, like just a vector. But it gives you the idea that it's a fixed size, which means this entire structure always takes the same amount of bytes in Borscht, no matter like how long the account ID. And let's see. So it has a parse date, then returns a timestamp. It takes, okay. Oh yeah, so timestamp in U32. So this timestamp in seconds. Okay, it reads the file, the first file, input, output, Borscht, and then reads the third one. Oh, yeah, and the multiplier is optional, so it reads the taser, has it 1. Then it checks the multiplier is positive. Open file, open CSV reader, then a bunch of variables, unique account IDs. Okay, deserialize. So this is probably the third deserialization. So it gets a record, wraps the record, get all this data. It seems like they doesn't need nearest decay unless the account is a valid account ID. I guess they need to validate the account ID. Okay, so get the account ID into a string, start timestamp parse, cliff timestamp parse, or start timestamp, okay? And the end timestamp is end date, start time and less than equal than cliff is less than equal than end timestamp, start time timestamp is less than end timestamp, strictly. So the duration of the lookup should be positive, the balance should be positive, then it does the minimum start timestamp from all start timestamps, then a maximum end timestamp from all end timestamps, then gets the account links, count ID with zeros, and then copies the account ID. Unique account ID insert. Oh, that's basically checks that all account IDs are unique in the in a CSV file. Cool. Balance check multiplication. So let's get the balance multiplied. Total accounts +1, total balance. Add balance so it doesn't overflow U128. And then it creates the fixed size account ID. What is data? Data is a vector. Oh yeah, so does serialize this to a vector. So this record gets serialized to a vector and just appended to the data. So basically data is just a vector of already serialized data. So you cannot really deserialize data directly, because if it was the valid Borsch, you need to put the length of the data first. Okay. Okay, so total not. So this is the stats. Then write a file and write data there, and that's it.
Yeah, so I guess the one thing about the how they're able to do that without like length prefixing is, I guess that's why they have the fixed size for the account. That's how they, like, I guess they're just assuming that each account takes a certain amount of bytes, so they don't actually need a length prefix it.
Oh yeah, because they can do the divide the data by this probably. Like the
Yeah, they're
global
probably
data
just
links.
they're probably just indexing each X amount of however large, however many bytes the fixed size account is.
Makes sense, yeah. Let's see. Okay, so that basically the binary, the tool that converts the CSV. So that's pretty straightforward. It converts a date to UTC timestamp at 000 if it can parse it. And then outputs the statistics, like total number of accounts, then total balance, start, and then timestamp. Okay, so next we'll look into the lookup. Okay, readme. Okay. Update this file. I have this file. When I build it, okay, it just copies the output to this file. Cool. All right, so Tamil lookup. So it uses SDK 3.1 contract standards 3.1 uint. Then sim 3.2. Cool. Okay, so this is the contract, and it uses fungible token, right? Because it needs to call fungible tokens. Storage key, accounts, timestamp sec, token account ID is account ID. Okay, gas for transfer call. It's probably a lot of the gas. Maybe don't need so much. Okay, so yeah, that's included as data. So basically they compile the data into the lookup contract. And then yeah, fixed size account idea, as you said. So it basically just hard-coded this number and calculate the number of accounts from the data. Max storage per account. So storage 1 yocto. Okay, so here's a U256 from uint. It's probably for mass. It's the same structure that was there. And there's just a count. Okay. It seems like it's the same as this, except it doesn't have a count ID in it. And it has the wrapped balance and claim balance. So it needs it for JSON. Okay, so main structure contract. We have a lookup map, account ID to account, token account ID, just an account ID, Skyward account ID, claim expiration timestamp, total balance, untouched balance, total claim balance. Okay. So from the post I read, what they do is there's something about unclaimed balance that goes to Skyward account when the expiration happens. So it's like a, I guess, Skyward specific, not just lockup. Okay. Stats. Again. Token account. Oh, it's basically just this structure, but in with JSON because of wrapped balances. It doesn't have a lookup map. Yeah, ideally what would be nice is we wouldn't have to do this. Like you wouldn't don't need to create a separate structure just for JSON. Like if like our default balance would be wrapped balance, then the only problem is serialization of account, but maybe you can do something like third skip. Then you have this structure that you can just return with the third. I guess you can also like do.
Yeah, I mean, you could just do a custom serialization or in deserialization, or I think there might be some sort of default function that you can call with Serde, if I remember correctly.
There's also like in your core we use something like UTF-12 DAC string or something that would assert this. I don't remember the exact syntax, but maybe you can do just custom decorator on these three fields, and then because you don't need to deserialize it, right? You only want to return it, so you would do something like this, and then this way you can return it. But ideally, yeah, that field would be just automatically deserialized, or like serialized. Once we especially switch to strict types, then we can just implement a Serde for this type if it's a balanced type. Okay, contract, new. So it takes token account ID, Skyward account ID, claim expiration timestamp, and total balance. Required storage. Takes storage usage. So if the contract is new, the storage usage is just the contract and access keys. Plus self-storage. which is 1000. Then max storage per account, which is 137, multiplied by the number of accounts in a lookup. So this is, yeah, that's from the file. And multiplied by cost. And then the balance should be higher than this. So basically, at initialization, the balance should cover all lookup accounts in the. So I guess it's just so you don't need to ask for storage when someone wanna use this contract. Then create a map and all the data. Total balance and touch balance is total balance. Total claimed is 0. Okay. Get account is a view call. It gets account ID and now lookup index option U32 and return optional account. And then internal get accounts, which is takes account ID, lookup option, returns get account ID from the lookup map and or else. And then if there's no such thing, then it checks if timestamp is less than expiration. So basically, if the expiration didn't happen, then it uses lookup index. Then parse lookup account ID, expected account ID lookup index. Okay. Expected account ID and lookup index, and it should return the account. Okay. So it checks that the lookup account ID is less than total number of accounts. Then it deserializes this fixed size account ID from lookup data. I see. Okay, that makes sense. So yeah, basically what it does is it looks at these bytes that don't have a length, but it uses the index of the account to calculate the offset, and then deserializes this record at this index. So that's probably done so you don't need to deserialize all of them. Then how I should know the lookup index? I guess you need to know the lookup index for the account that you're trying to get before you can get it out. And a way of doing this is probably if you have this binary on the side that tries to look up the account. Then you can look at every account there and then find your account ID and get it there. Okay, account ID from UTF-8, account length usage. Okay, so it reconstructs the account ID and then compares the expected account ID to this account ID. Okay, and then it returns the account with full balance and no claim balance. Okay, so yeah, that basically allows to quickly pull data from the contract itself, from the binary of the contract. So if you have ton of accounts, then that would be pretty efficient. Except like if the contract binary size is pretty large, then you essentially like maybe limited by how many accounts you have. So you have 93 bytes. That's yeah, in 100 kilobytes you can get at least 1,000 plus account. Yeah, 1,000 plus accounts. I guess another way may be like you can save on this by using a hash of the account ID. So instead of comparing the actual account to account, you can compare account to a hash.
I'm still a bit confused why you couldn't just length prefix and not have to store the 64 bytes for every account.
So then the size will be different, right? So this will not be a fixed size account ID. So you'll need to pass. Oh yeah, you can just pass the offset, right, instead of index. Then you can deserialize the structure, but you cannot prove that this is exactly the boundary of the account record. Because here you have a proof because you just multiply it by the size of this. So you know that offset is always starts from a multiple of this. But if you have a variable size records dumped into the structure, then you need to somehow.
Well, you can just deserialize it from a reader of those bytes, can you not?
Yeah. But I mean, that may have a conflict in some place. So for example, you can get the offset from uneven place. So let's say this was not a lookup index, but something like offset. You pass the offset in this data, and then you deserialize this data at the given position. And if it's okay, it still doesn't prove anything. Well, unless you compare account ID, right? You can compare account ID, and if it works, then it's very likely that you correctly deserialize the file, because chance that there's a collision on account IDs is pretty low. Does it make sense? So let's say we have something like len, so 4 bytes for links, then you have account ID, then you have time, well, without the like underscores, and then you have balance, the 16 bytes. And then the next record starts with again this, but now account ID can be a different size. And in case you pass something like incorrect position here, then you'll try to start deserializing, and for some reason, like magically, it may actually work out that you get exact number of bytes to deserialize the account ID. But then, yeah, as you said, the account ID, expected account ID, not gonna match. So it should be possible as well. Anyway, let's see what it does with the account. So it returns the account, and then if you call claim, then you also need to look up index. Account ID is the predecessor. You get the account ID using the predecessor in a given lookup index, and then claim. So the account should exist. Then a current timestamp, and it calculates unlocked balance. Okay, if the current timestamp is less than cliff, so it's before cliff, and then it's 0. If a current timestamp is more than n timestamp or equal, it means it's a full balance. Otherwise, total duration is n timestamp minus third timestamp in nano. What is the nano? Just multiplication. Okay. Past duration is current timestamp minus start timestamp. Yeah, because we are after the cliff, so this is positive or 0. Then past duration multiplied by account balance, total balance, divided by total duration. So it basically just computes how much balance you get so far after a cliff, or like from start. So it's similar to our lockup contract in core contracts. Okay, so you got the unlocked balance. Claim balance is unlocked balance minus claim balance. Okay, claim balance, we say the claim balance. Total claimed is plus claim balance. Save the account. If the account is none, it means there was no previous record in the accounts. New claim, have to remove this from untouched balance, okay? So it removes it from untouched balance. So like entire balance is now touched, even so it can be not fully claimed. Okay, if claim is positive, then it does the transfer call to account ID with the claim balance. To token account ID 1 yocta gas for fun with T transfer call is returned. Okay, so yeah, basically what it does is it calculates the claim balance, and this is a new balance that just unlocked, comparing this to the from the previous claim balance, and it saves how much it's already claimed, saves total claimed on the entire lockup, updates the untouched balance, if it's a new claim, and then if the balance is positive, then it issues a transfer from self to account ID. Okay. But you need to be registered on this token. So if you don't register on fungible token as a account ID, the predecessor, then this call will just fail, and this contract will pretty much keeps the token because it's already updated that the total claimed is increased, so it just ignores it. Okay, get stats, just returns stats. Okay, that actually can be done with this. So you can do get full self and just don't need to clone it. Okay, donate to treasury. So this is probably what specific to Skyward. Okay, assert the current block time is after at least the expiration. Claims not expired. If untouched balance is positive. So this is the untouched balance that we did here, right? It's untouched balance that is. So when you touch the account, even so you didn't claim everything, but you do this before the expiration, then your balance is unaffected because it gets into the map. So here you will get it already saved, so you're not gonna get expired. Okay, if untouched balance is positive, terminating remaining untouched token balance from blood to Skyward Treasure. Untouched balance from here to here. We'll log this message. FT transfer call. Skyward untouched balance. Message. Donate to treasury. Okay, this is a memo and this is the message in a transfer call. So this will be passed to the contract, the receiving contract, which is Skyward account ID. And then it removes the total balance, the untouched balance, and resets the untouched balance to 0. Okay. And use near balance. So it basically gets all the liquid near on this account. Skyward. And just transfer this to Skyward account ID. Magic. But when you transfer out all the storage or like extra storage, you will not have any spare bytes to write. So next time you're trying to write something on this contract, it cannot add more storage because it has 0 free balance. unless you like remove it or replace it. I guess once it expires, it cannot add anymore. Okay. Anything else? No unit tests. So this is the tests. Simulation tests. Okay. Anyway, we can take a look at this later. Do you have questions on the lockup contract?
Yeah, I think that the main thing that's confusing about me to me is just the fact that all of the accounts like serialized to Borsch are included in the actual contract bytecode instead of just on initializing. Why not just store those things in storage? Like they are being like lazily stored in storage, but like that data that is being stored at the like in the contract bytecode is never obviously deleted. So like, is there really that much of a cost to storage that it's worth it to like increase the amount of bytes in the actual contract and then lazily, store that later? I'm kind of confused about what the motivation there is.
Well, storage in this like persistent storage is same cost on a protocol level, so it's not that different. Like you can actually do the initialization and pass this data at the initialization directly. And then depending on the size of this, it's pretty expensive operation to write it. Probably right now, it's probably more expensive to write it that way than deploy, but that's probably just because right now deploy costs are too cheap. So deploy cost might be a bit broken. But in the future, deploy actually going to be more expensive. So this operation might be more expensive to include.
Right,
So
gotcha. Yeah, that's the only thing.
It depends on the size of this data as well. So let's say we deploy in only like 1 kilobyte of lockup data at the init, then it doesn't matter where it belongs to because it's fairly small.
Yeah, but then the thing is, it would still be duplicated whenever these accounts are interacted with, because like inside the contract state, the accounts would be put into the lookup map. So you'd basically have you'd have one entry in the storage anyway, and then also in the contract bytecode. So it kind of seems a little bit redundant to me. That's the part that's primarily like confusing the motivation behind.
Yeah, that you're right. Yeah, maybe, well, so why not store it in the init? Then when you're trying to look in your account, that what would be expensive, because when you're trying to look up an account that is not there for the first time, then you need to pull all accounts from the storage, because we cannot pull the partial register. So like we will be able to read this key into a register, but then from this register, I don't think we have a way to read only like part of the register into the output. That actually if we do storage read. Then it calls storage read. Right, so this is gonna read all data into register. But then from register, yeah, it just takes a pointer. So pretty much we cannot read only like one account from the storage. So we'll have to, every time we look up an account, we have to read all accounts. So let's say we're talking about more than 1 kilobyte, but maybe like 10 kilobytes of accounts, then you would have to pull this 10 kilobytes for the account.
Yeah, I'm a little bit confused about that because what I meant by is I don't mean storing all of the like serialized bytes in storage under one key. I just mean like in some sort of, because it's already being stored in a lookup map, or like if you need it to be indexed, like why not just have it as some just sharded structure?
Oh yeah, good point. So the reason for batch storage is like we cannot do too many writes at once. It's more expensive to create multiple keys than one key with large value. So like multiple small keys are more expensive than one key with large value. So like depending on the number of accounts, it's probably not possible to do in one go. So you may need to do this in multiple initialization calls, which is probably doable. So it's something like you call new, and then you say something like add accounts and pass a list of accounts, and then it just drops them into lookup map.
Right, gotcha. Yeah, I guess with those cost constraints, that could be a motivation for it.
But yeah, it would be cool. I think Matt also asked me on Discord whether there's an efficient way of doing it, like a bulk write. In theory, because the accounts are stored in a bytecode right now, then some data doesn't need to be duplicated. So in theory, you just can, in this structure, like this data can be pulled from the contract as well as balance. So what you really need is something like lookup index and whatever it was, usize. Okay. And then every time you access an existing account that already was pulled and has a claimed balance, you just look up the account by index and get all these fields out that you need, like all 4 of them. And then yeah, you need fields for Borscht separately. So it probably worth doing it. Anyway, this was cool. I like the contract. It seems very well done. A bit confusing, but yeah. Yeah, thanks everyone for looking into this and listening. It's a cool contract. I think we should review the main contract at some point as well next time. Okay, thanks. Bye.